responsible for the closeout crew. They're responsible for everything happening on the launch pad. They're responsible for your safety here, that NASA test director. So you'll hear NTD a lot over the speaker, and that's who you're listening to. And then the other one is OTC, which is Orbiter Test Conductor. And that's the person in the firing room. This building right over here, it's a kind of a low-slung building. It's got a glass front. And the firing room, where the people actually are controlling the launch countdown, are inside of that room. And the Orbiter Test Conductor is in charge of that room and the actual launching of this shuttle. Okay, so then you'll hear those things, and then you'll hear CDR, which is Commander, and that's Chris Ferguson, and then you'll hear PLT, which is the pilot, and you'll hear MS1 and MS2. And so you'll hear those, and that's the actual crew, so you may hear CDR, OTC, and then you'll hear Chris Ferguson talking to the Orbiter Test Conductor, okay? So that's the first thing. And you asked me about speeds, because you're going to hear a couple of other calls. So at T-minus, well, first of all, you're going to see the launch countdown clock stop at 20 minutes, and you're going to hear a collective sigh. But there is a planned, usually about a 10-minute hold at the T-minus 20-minute mark. So when the countdown clock stops at 20 minutes, be sure that there is a built-in hold there, and that allows us to catch up with any kind of anomalies going on. And then you're going to see the countdown clock start again. And it's not gonna match up with the launch time, because we got a launch time, I think it's 11, is it still 11:26 or 11:35? Right in there, the launch window, and you're gonna see the countdown clock out here is not gonna match, because at T-minus 9 minutes, the clock is gonna stop again. And it's gonna stop for about 40 to 45 minutes. And that allows us, again, time to get caught up on everything. It allows the navigation and trajectory system on board the space shuttle and what we're calculating here, and the station's coming, and so we're recalculating the exact trajectory of the space shuttle, and so we get it down to the second that we need to launch. And so that T-minus 9-minute hold will last somewhere between 40 and 45 minutes, and it'll be to the exact second, so we can intercept the space station that's coming over. Then at T-minus 15 seconds, you may see, actually you probably won't see, you may be able to see the water from here, but we deluge the pad with millions of gallons of water. And you might ask why, and you've heard the stories about STS-1 when we didn't dampen the vibration on the launch pad with water, and when we went out to refurbish the pad for the next shuttle launch, there were some things damaged by the sound, by the decibel level at the launch pad. And so now we actually deluge the pad with water, and that happens at T-minus 15 seconds. You'll actually hear it over the PA system. It's like a rainbird system where water will shoot out on the pad. And when you're looking at it from the space shuttle, I had wrist mirrors looking through the upper windows, and you could see it's like a waterfall coming down behind the space shuttle. It happens at 15 seconds. At T-minus 6.6 seconds, the shuttle main engines will light. And so you'll see a lot of, and I'm trying to think, the orientation, I think, is the back of the shuttle was toward us, I think, and so from this vantage point. So you'll see a lot of smoke and steam coming out of the back side of the shuttle. In fact, there'll be a fairly large plume about 6 seconds before liftoff. And those shuttle main engines have to come to 104% and stable with no red line malfunctions for the fire command to be sent to the solid rocket boosters. And then when that happens, of course, at T0. And then you're going to see the thing go. Now, when you watch the shuttle, it's gonna, in 12 seconds, it's going to lie on its back. And we do that for a couple of reasons. The antennas are on top of the shuttle, up by the top of the cabin. And we're launching into a 51-degree inclination, so this shuttle is going to actually go up and parallel the East Coast. And so we use a lot of emergency ground landing sites and communication sites up the East Coast and in Bermuda that we use these antennas for. So that's one reason. Then the other reason is the shuttle, although it's a cinder block with little stubby wings, it does have wings and it wants to fly. And but we want it to stay on the external tank, and so laying it on its back with the roll program will actually give it a negative angle of attack, so it helps us with the lift vector on the wings, so we don't have a lift vector on the wings as it's in first stage. And so you'll see those things as well. Now that will happen and you'll hear Atlantis say, Chris Ferguson will say, now he'll see the roll command go in before the shuttle rolls, and the roll command will go in, and then the shuttle will roll on its back, and you'll hear Houston, Atlantis, roll program, and that's just the commander telling Houston that that the roll program was correct and it was complete, and then you'll hear Houston respond, and then the next call you hear, this is my cheat sheet, so I got all my Soyuz stuff memorized, but I forgot my shuttle stuff, and at 1 minute and 10 seconds, that's when we actually reach the transonic speeds, obviously, then through the sound barrier. And am I going way over, guys? Okay, Shepard Kirkby. Okay, Shepard Kirkby. So at 1 minute and 10 seconds, you're going to hear "Go at throttle up," and what that is saying is we've already gone through the area of max dynamic pressure. Okay, the maximum forces on the vehicle because we're shedding the shock now, and we're coming through the sound barrier. And when we're safely through the sound barrier, we actually, before we get to the sound barrier in transonic region, we throttle the engines down. The engines come down to about, if I remember correctly, about 72% to decrease the loads on the shuttle because it's a pretty dynamic environment. Once it gets through the barrier, then we throttle the engines back up to 104%. And when Houston sees that all three engines are at 104% and the commander confirms, you'll hear the call, Atlantis, go at throttle up. That means you're go, everything looks good with the engines. And you'll hear that at 1 minute and 10 seconds. At 2 minutes and 5 seconds, that's the length of first stage, we're going to get off the SRBs, and you'll hear, especially the folks that work here as engineers preparing the shuttle, you'll hear a massive sigh of relief when we get off those boosters. And because when you're on those things, you're pretty much along for the ride. You can't throttle them, it's solid fuel, and when you light those things, you're going somewhere. So at 2 minutes and 5 seconds, you get off the solid rocket boosters, you'll be able to see it. You'll be able to see the trails come off to the sides as the booster comes off, and you'll hear over the PA that the booster officer confirms good SRB set. So you'll see that at 2 minutes and 5 seconds. At 2 minutes and 32 seconds, at Mach 5.6 or 4,000 miles per hour, you'll hear a call to the shuttle. Now what we're doing is, as we're ascending to space, it takes about 8.5 minutes, pretty dynamic environment, and you have different abort criteria. The first being returning to this launch site. You can actually return the shuttle here and land. And so these are boundary calls. So at 2 minutes and 32 seconds, you're going to hear Atlantis, Houston, 2 engine Zaragoza 104. And what that means is that Zaragoza, Spain is our transatlantic abort site. And so now if an engine fails, we can make it, and we still have 2 good engines, we can make it to Zaragoza, Spain on those 2 engines and land at 104%. At 4 minutes and 3 seconds, at Mach 8, at 5,700 miles per hour, you'll hear the call negative return. And what that means is we're too high, too far downrange, and going too fast to be able to turn around and land here at Kennedy. Okay, so that happens in 4 minutes. And we're going Mach 8 at that point. At 4 minutes and 38 seconds, at Mach 9.5, which is about 6,000 miles per hour, 6,600 miles per hour, you'll hear a call that's press to ATO, and that's abort to orbit. Okay, and what that means is you can lose a shuttle main engine and have 2 good engines and still make it to orbit. And so that's a great call for the commander to know, because now the commander's got on his mind, whenever you're taught as a pilot, when the engine quits, where are you going to go? And so that's the boundary call. It's like, okay, if I have an engine quit, I can still make it to orbit. So you'll hear that call at 4 minutes and 38 seconds. At 5 minutes and 21 seconds, at Mach 11, which is about 8,000 miles per hour, you'll hear the call, and these are all coming from Houston. You'll hear Houston Atlantis single engine Ops 3 Zaragoza 109. And what that means is, he's telling Chris Ferguson, the commander, is like, hey, if you lose an engine, you can land in Zaragoza at 100, but if the other 2 engines take them to max throttle at 109%, and you can make it across the ocean on 2 engines. At 5 minutes and 56 seconds at Mach 13, which is about 9,000 miles per hour, you'll hear the call single engine Zaragoza 104. And what that means is the shuttle now can lose 2 engines and have 1 good engine and make it all the way to Zaragoza. And then at 6 minutes at Mach 14, which is the call that you want to hear, is press the MECO, which means if we lose 1 engine, we can still make our nominal main engine cutoff. And that happens at 6 minutes, 13 seconds, Mach 14, 10,000 miles per hour. At 7 minutes, at Mach 17.8, it's about 13,000 miles per hour. You'll hear single engine press, which means you can lose 2 engines and still make it to MECO. And then you'll hear MECO at 8 minutes and 30 seconds, Mach 25, 17,500 miles per hour. You'll hear MECO, and that's when you can clap. And you'll hear over the speaker, you'll hear MECO confirmed, which is main engine cutoff. So you'll hear a big round of applause when that happens as well. Did they answer your question?